So question 1 is about soluble salts being formed by reacting metal oxides with acid. So we are looking at C4 chemical changes here. Give one type of substance that can react with an acid to form a soluble salt. So they want one other, so they've told you metal oxides. What else reacts with acid? And this is where you'll go into your general formulas that you might have used in the past. So metal plus acid makes salt plus hydrogen. Metal carbonate plus acid makes salt plus water plus carbon dioxide. So you've got a few options there. You might remember acid plus alkali makes salt plus water. A few different ones for you to choose from. The next question, calcium nitrate contains the ions Ca2+ and NO3-, gives the formulae of calcium nitrate. So we've got to remember, in a stable compound, the net charge is going to be 0. So with a 2+ and a minus charge on the NO3, we need another NO3 for the net charges to cancel out to be 0. They will not penalise you if you have left the charges in. So if you wrote Ca2+ and NO3- and put the 2, they're not going to mark you down for that bit. So we have a 6-mark question based on an experiment, and they've asked you to describe a method to make pure dry crystals of magnesium sulfate from a metal oxide and a dilute acid. So we're going to state a method basically, but we've got to work out what chemicals we're going to use, and we can get that information from the question we're given. So we're told we want to make magnesium sulfate. So we need a source of the magnesium, and we need to have an acid that will produce sulfate salts. So we're going to be using a metal oxide, so it must be magnesium oxide, and acid, so it must be sulfuric acid, so that we can make a sulfate. You are expected to know the different salts made from different acids. That's sulfuric acid, hydrochloric acid, and nitric acid. And you are meant to know from C4 your general equation, so metal oxide plus acid makes salt plus water, and so forth. So make sure you have some flashcards on that. Now, when dealing with these 6-mark questions, you need to be aware that they are levelled. So for a level 1, to get 1 or 2 marks, the method won't necessarily work, but there are some relevant steps identified, but it's not necessarily very clearly logically laid out. Level 2, you might not have the perfect method, it might not get the right thing, so maybe you pick the wrong chemicals, but if most steps are identified in the process, you could get yourself 4 marks. To get a level 3 and get 5, 6 marks, you want to have a valid outcome, so you've got the right chemicals, so you're going to be able to make those magnesium sulfate, and it's going to be a nice logical approach. So you want to think about how can you best lay out this answer. Have a pause the video, have a think about how you would answer this one. So I find it helpful myself when describing a method for an experiment to draw diagrams. So you can, and you'll get credit for drawing diagrams and labeling them up correctly or putting the method around them. So don't be afraid of using diagrams, because sometimes it's much easier to show how the equipment is set up than describing lots of words. So you can use bullet points for these 6 marks question. That is perfectly acceptable, so don't be afraid to use it if that helps you approach it in a logical fashion. So stage 1, you're going to warm the sulfuric acid in the beaker, and then you're going to add the magnesium oxide. You're going to stir it and continue adding the magnesium oxide until it is in excess. So you'll see little deposits on the bottom of the beaker. They're not reacting, they're not disappearing when you put them in. You then want to filter out that excess, and you're going to use a funnel and filter paper. So you are kind of stating the obvious of some of these steps. And then finally, you're going to heat the solution in an evaporating basin until crystallization point, leave to crystallize, and then pat dry. You could also say you're going to leave that to evaporate in the room for a week or so until the crystals are formed. That is also perfectly acceptable. So to get that level 3 mark, you needed to make sure you had the acid correct and the oxide correct. So we've done that. Our approach is logical. It will produce a valid outcome, and we've got ourselves 6 marks here. So question 2 is all about metals and metal compounds. And the first part links to C2. So we have iron pyrite. It's an ionic compound, and we're showing a diagram there. And we can see it's lattice structure, lattice being repeating pattern. Determine the formula of iron pyrite using the figure. So we can see for every 1 iron there are 2 sulfur. So the formula is FeS2. Can I remind you to be really careful with the casing of your letters? If you did a capital E in this one, you would lose the mark, or if your S looked like it might be lowercase s, you would also lose the mark. So be very careful. Upper and lowercase letters are important in chemistry. So 2.2, bit of C1 revision here. An atom of an iron is represented as shown. Gives a number of protons, neutrons, electrons in this atom of iron. So, number of protons equals the atomic number, and that's the bottom number shown here, so it's 26. Number of neutrons is going to be the mass number minus the atomic number, so that is going to be 30. And the number of electrons, now as this is an atom and not an iron, the overall charge must be neutral, so we must have the same number of electrons as protons. Now remember, you have a periodic table in your exam and you can use that to help you, and it will also have a nice label and key on, so it does point out the atomic proton number on there, and that could be a useful clue. 2.3, we are also looking at C1. Iron is a transition metal, sodium is a group 1 metal. Give 2 differences between the properties of iron and sodium. There are lots of different ones you can give, so here are just a few of them. Iron is harder, iron is less reactive. Ions have different charges, ions can be catalysts. You can also say converse statement, so sodium is softer, sodium is more reactive, and that is perfectly valid too. And there are a few more I haven't listed on here. So we're now going back to C4. Nickel is extracted from nickel oxide by reduction with carbon. Explain why carbon can be used to extract nickel from nickel oxide. So looking at the reactivity series, you can see that carbon is more reactive than nickel, and this means that it can displace it. And so, with 1 mark saying that carbon is more reactive, 2nd mark is for saying that it displaces nickel. So here is a bit of C3. We're asked to calculate the percentage atom economy for the reaction to produce nickel, and we're given some information about the atomic masses and their relative formula masses. And significantly, they want us to give our answer in 3 significant figures. So this is an equation you need to know and be comfortable using. So first step is calculate the MR of the reactants, and then we can plug all the numbers in. So that gives us 59 divided by 87, times that all by 100, and that gives us, to 3 significant figures, 67.8%. So we have got some electrolysis being shown here. We've got a simple cell, we've got 2 electrodes in the electrolyte. Which combination would not give a 0 reading on the voltmeter? So we're looking to get a potential difference, so we need to have 2 different metals. That rules out the first 2 options, and we need the charge to be carried across the solution, so we need to have sodium chloride. So alkaline batteries are non-rechargeable. Why do alkaline batteries eventually stop working? Well, why does any chemical reaction stop? The reactants are all used up, or they've run out. Where does that affect? Why can alkaline batteries not be recharged? It's not a reversible action. So we're now looking at hydrogen fuel cells, and they want to know the overall reaction for the hydrogen fuel cell. So hydrogen plus oxygen makes water. So identifying the other reactant as oxygen gets you 1 mark. You then need to balance the equation. So we can see on the reactant side, on the left hand side, we have 2 hydrogen, 2 oxygen. And on the product side, we have 2 hydrogen and 1 oxygen. So we need to get 2 oxygens. So I'm going to put a 2 there. So I now have oxygens balanced on both sides, but I now have 4 hydrogens on the product side and only 2 on the reactants. So I'm going to add a 2 here to make sure it is balanced. So we have another 6-mark question here, and we are given some data about different ways to power electric cars. So we're comparing a hydrogen fuel cell and a rechargeable lithium-ion battery. And the question asks us to evaluate the use of the hydrogen fuel cells compared with the rechargeable lithium-ion batteries to power electric cars. Use table 1 and your own knowledge. So you can just use a table and you'll get a lot of information, and that'll probably get you 4 marks out of 6. But they are expecting you to make links to other knowledge to push you up to a 6 marker answer. Now the key word they have in this question is evaluate. So you're looking at the pros and cons of the different options, but you ultimately have to make a judgment. Without a judgment of any description, which one you think is best or worst, then you are going to be restricted. If we look at the criteria, which I'll put up in the next slide, for level 1, they want some relevant points made, but not logically linked. For level 2, some logically linked statements are given. There may also be a simple judgment. But to get a level 3 mark, then you need to have a judgment that is strongly linked and supported by some data. So have a think about how you would answer this question before looking at the answers. So here's the official mark scheme, and it lists some of the content they might expect to see, but there might be other stuff that you raise. You may do some calculations even based on some of the numbers you've got to back up your conclusions. You do not need to have every single bullet point down to get the full marks. What they're looking for is strongly linked statements. So because of this, this will happen, that kind of thing. You are allowed to use bullet points, as I said before, and you're allowed to use a table. So if you wanted to make a table with pros for each option, that is perfectly valid. The important thing is that you put a judgment call at the end, because that's what you need for evaluate, not just identify the pros and cons, but say, based on that, which one you think is best, worst, whatever that might be. So this question is looking at different models of the atom. So we're linking this to C1. Which diagram shows a plum pudding model? That's going to be B. We've got our positive ball with random currents of negative charge. Which diagram shows the model of the atom being developed from alpha particle scattering experiment? That's going to be C. And which diagram shows the results of Bohr's work? That's going to be A, where we have our orbital shells. So define the mass number of the atom. So that's going to be the number of protons plus neutrons. Nice and straightforward. 4.5, element X has 2 isotopes. Their mass numbers are 69 to 71, and we're told their percentage abundance. Estimate the relative atomic mass of element X. This is where we do weighted averages of isotopes. And to do that, you times the mass number of each one by its percentage abundance, and add it to the mass number times percentage abundance of any other isotopes there might be, and divide by 100. So, in this case, it would be 60 times 69 plus 40 times 71 divided by 100. We will be ticking this box here. So, we're told Chadwick's experimental work on the atom led to a better understanding of isotopes. Explain how his work led to this understanding. So, you may have forgotten what Chadwick did. His experiments led to the discovery of the neutron. And the other part of the question is about isotopes. So what is an isotope? So an isotope is something that has the same number of protons but a different number of neutrons. So scientists were looking at elements with different mass numbers and getting a bit confused and thinking they were different elements when that wasn't the case. Now, you'll get marks for saying Chadwick discovered the neutron. You'll get another mark for saying isotopes have the same number of protons, and you'll get the third mark for saying they have a different number of neutrons. Okay, so basically you're getting 2 marks for defining what an isotope is and 1 mark for saying what Chadwick's link was there.